page, hold on one second please, page 114, 7, 8, 10, 11, 12, 13, 14, and 33 through 36. Let's go ahead and get started with number 7 and 8. The directions say to draw a line L and a point P that's not on L, and then draw L2 as indicated. So let's go ahead and draw L1. And we will label this line 1, and line 2 is parallel to line 1 and contains point P. So here's a parallel line. Hopefully it's parallel. Doesn't look very parallel to me. Let's try it again. Here we go. Decent enough. And we will call this line 2, and it's supposed to contain point P. Piece of cake. Moving on to number 8. L2 is perpendicular to L1, and it contains point P. So here's L1. And then here is the perpendicular line. We're going to call that L2. And then not only is L2 perpendicular to line 1, line 2 contains point P. Alright, moving on to number 10. If negative 1, 4 is a solution of x minus 2y equals b, then what is b? Well, it's really pretty simple what to do here, students. This is your x, this is your y, so where the x is, I'm going to substitute negative 1. And where the y is, I'm going to substitute 4. And then I'm going to solve for b. So here we go. I have negative 1, negative 8 equals b. Because a negative 1 is just a negative 1, and negative 2 times 4 is a negative 8. And now we'll combine these two terms. A negative 1 and a negative 8 is a negative 9. So there we go. So b is negative 9. All right. Moving on now to number 11. The method we're going to use is the graphing method. So let's solve number 11 using the graphing method. Real quick here, I'm going to get a coordinate plane. It'll take just a second here. Hopefully. And it's not what I wanted, so we'll try this again. And that's a little better. And here we go. Let's go ahead and solve this linear system by using the graphing method. Alright, so I'm going to very quickly grab we're going to graph each equation. Let's go ahead and start with our first equation here. X minus y equals 0. I'm going to put a 1 in for x real quick. Put a 1 in for x. 1 minus y equals 0. Bring the 1 over and make it a negative 1. And I'm left with negative y equals negative 1. And so if negative y equals negative 1, then y equals 1. So when I put 1 in for x, I got 1 out for y. So one ordered pair for this top equation is 1, 1. Now I'm going to substitute 2 in for x. I'm just picking these numbers at random. 1 and 2 are nice small numbers. So 2 minus y equals 0. Bring your 2 over and make it a negative 2. And we're left with negative y equals negative 2. So if negative y equals negative 2, then y equals 2. So when I put 2 in, I got out of 2. So I can quickly graph my first line, 1, 1, and 2, 2. There we go. Okay, so we'll sketch that line pretty quickly. Slide it up here so it fits. And let's continue on. Alright, let's go ahead and graph the second equation. I'm going to put a 1 in for x, so 5 times 1 minus 2y equals 6. 5 times 1 is 5. Bring the 5 over and make it a negative 5, so we're left with a negative 2y equals 1. And then divide both sides by a negative 2, and 1 divided by negative 2 is a negative 1/2. So, negative 1/2. So, when I put in a 1, I got out a negative 1/2. Alright, now let's put a 2 in for x. And 5 times 2 is 10. Bring your 10 over and make it a negative 10, and you're left with negative 2y equals negative 4. Divide both sides by negative 2. A negative 4 divided by a negative 2 is 2. So when you put in a 2, you get out a 4. Okay? So we're at 1. The first ordered pair is 1, and then down a half, so negative 1/2. And then the other ordered pair is over 2 and up 4. 1, 2, 3, 4. So let's go ahead and connect those 2 points, okay, the best that we possibly can. And it looks like, I'm not sure exactly where these 2 lines are intersecting. Okay, I do see my mistake now, and I apologize, students. I was wondering, that didn't look right at all. When we put a 2 in for x, we got a 2 out for y, and I'm not sure why I put 2, 4 up here. I should have put 2, 2. So my fault. So my first ordered pair is over 1 and down a half, and my other ordered pair is over 2 and up 2, which is where that point should be right there. And I think my coordinate plane got moved a little bit, so there we go. So over 1 down a half, and then over 2 and up 2, and then sketch your line. So these 2 lines are intersecting right here at over 2 and up 2. So the answer to this linear system would be 2, 2. Now you could check your answer by taking 2, 2 and substituting it into the first equation, and you would get out a true statement, and then substitute into the second equation, and you would get out a true statement, okay? All right, moving on to number 12. Number 12, we're going to use the linear combination method. Linear combination, okay? So here we go. Let's see here. It looks like the easiest variable to eliminate would be your y's. I have a positive 1 right here, even though I can't see the 1. So I'm going to multiply this bottom equation by a negative 3. And by doing that, I will then end up with a negative 3 right here for my y, and my y's will cancel. So my top equation is going to remain 2x plus 3y equals 5. My bottom equation would be negative 3 times 3 is negative 9x, negative 3 times y is negative 3y, and negative 3 times 11 is negative 33. Now let's combine these two. These will cancel. On the right side, I'm left with negative 28. Over here, I'm left with negative 7x. We're going to divide both sides by negative 7. And if I do that correctly, a negative divided by a negative is a positive. I will get out 4 for x. Now, students, it does not matter where I substitute 4. I can put it into this x or this x or this x or this x. The only reason I'm going to use this equation right here is because I have room underneath it to do work. That's the only reason. So here's my x. I'm going to put 3 parentheses 4 plus y equals 11. 3 times 4 is 12 plus y equals 11. Bring the 12 over and make it a negative 12. And y would equal a negative 1. So there's your answer. 4 comma negative 1. 4 comma negative 1. Okay? Now I believe in number 13 I've asked you to do it all 3 ways. So it'll take a little bit of time, but that's okay. Let's do the one thing I wanted to show you guys is let's definitely learn to eliminate our fractions, okay? That's real important to do. And also, let's get a coordinate plane right here so we can use that. Okay? Now, I don't want to try to solve this linear system if there's fractions all through it. So I notice my top equation has denominators of 3 and 3. So I'm going to multiply the top equation by 3. I notice my bottom equation has denominators of 5 and 5. So I'm going to multiply the bottom equation by 5. And here's what we'll get. 3 times 2 over 3 would be a negative 2x. 3 times negative y is negative 3y. And 3 times negative 7/3 would be a negative 7. Okay? Now let's take our 5 and let's multiply it through the equation. 5 times 2 over 5 would give me 2x. 5 times negative y would give me a negative 5y. And then 5 times negative 1/5 would give me a negative 1. Okay? So there we go. I have totally taken this original equation here and I've changed it and converted it over to this here, which as you can see is a lot easier to use than the original equation. So I'm going to use this for the rest of the problem. Okay, so here we go. Why don't we go ahead and do elimination first? I mean, right away when I look at this, I see that my x's are ready to eliminate. I have a positive 2x and a negative 2x. So right now, if I add these two equations together, the x's are going to eliminate, which is really, really helpful, okay? So these cancel. I'm left with negative 8y equals negative 8. Now divide both sides by negative 8, and y equals 1, because negative 8 divided by negative 8 is 1. So there. Now I know what y is, 1. Now it doesn't matter if you use the top equation or the bottom equation. I'm going to take the top equation, negative 2x minus 3y equals a negative 7, and where the y is, I'm going to substitute 1, because I now know that y equals 1. Okay, so here we go. Negative 2x, negative 3 times 1 is negative 3, equals negative 7. Bring your negative 3 over and make it a positive 3, and you're left with negative 2x equals negative 4. Divide both sides by negative 2, and x equals 2. So there's your answer, 2, 1. That's called the linear combination method. Now let's use the substitution method, okay? So here we go. What do we have here? Well, we had negative 2x and a positive 2x. So let's fix that real quick. And here we go. Negative 2x, negative 2x. No, that's not right. Oh, let's see here. Mr. Earhart, come on. Let's see what we got. Okay, so the bottom is a positive 2x. Okay. All right, here we go. So now, let's use the substitution method, okay, students? The substitution method. Now, usually, you're looking for a variable that does not have a number with it. And in this case, this x has a number, this x has a number, this y has a number, and this y has a number. So we're in a little bit of trouble, okay? So here's what we're going to do. It's not a big deal, but we're just going to go ahead and choose a variable and get x or y by itself. Now, for no certain reason, I'm just going to choose to get this x by itself. We're going to have some fractions, and it's going to make the problem a little more difficult, but we'll be okay. So here we go. We have 2x minus 5y equals negative 1. So I'm going to bring the 5y over and make it a positive 5y. So negative 1 plus 5y. And now we're going to divide everything by 2. So divide by 2, divide by 2, divide by 2. X equals negative 1/2 plus 5/2 y. Okay, so what I'm going to do now is I'm going to take my top equation, and everywhere there's an x, I'm going to put this expression right here. Negative 1/2 plus 5/2 plus negative 1/2 plus 5/2 y. So I have negative 2, then I have an x, so I'm going to put a parentheses, and then negative 1/2 plus 5/2 y. Now, all of this here went in for x, okay? And then bring down your negative 3y equals a negative 7. Now, let's solve this equation. I think we can all agree that on the right side of the equation here, there's really no simplifying we can do. So I'm just going to bring down my negative 7. Now, over here, I have a 2 that I can multiply through the parentheses, okay? So negative 2 times negative 1/2 is a positive 1, and a negative 2 times a positive 5/2 is a negative 5y, and then minus 3y. Now, I'm still not done simplifying. I have two y terms I can put together here and here. So a negative 5y and a negative 3y would be a negative 8y. So 1 minus 8y. Then, in order to solve for y, we're going to bring this 1 over, and we're going to make it a negative 1. And so we're left with negative 8y equals negative 8. So y equals 1. So now I know what y equals. Now we come over here to where our x expression is, and where y is, I'm going to substitute 1. So negative 1/2 plus 5/2 times 1. Okay, so x equals negative 1/2 plus 5/2. And if you're really bad with fractions, you can use your fraction button on your calculator, and you can type into your calculator negative 1/2 plus 5/2, and you will get 4 over 2, which is 2. So there's your answer, 2 comma 1. 2 comma 1. Okay? And then last but not least, we're going to use the graphing method very quickly here, and we will do it very quickly. Here are your two equations right here, and so we're going to graph each equation, and when we're done graphing each equation, we will then see where the two lines intersect. Okay, so let's put that here, and did not mean to do that. Let's go like that, and did not mean to do that. Let's go like that. And here we go. All right, let's go ahead and put 1 in for x real quick. So negative 2 times 1 minus 3y. What we're doing now is we're trying to graph each equation, okay? And we're going to graph each equation by putting numbers in for x and getting y values out. So I'll put a 1 in for x. Negative 2 times 1 is negative 2 minus 3y equals a negative 7. Bring your negative 2 over and it becomes a positive 2. So we're left with negative 3y equals negative 5. Now divide both sides by negative 3, and a negative divided by a negative is a positive, and 5 divided by 3 is 1 2/3. So one ordered pair would be 1 comma 1 2/3. Okay, now let's go ahead and put 2 in for x, and let's see what we get out. Okay, let's put a 2 right here. Negative 2 times 2 is negative 4 minus 3y equals negative 7. We're going to bring the negative 4 over and make it a positive 4, and we'll be left with a negative 3y equals a negative 3. Divide both sides by negative 3, and negative 3 divided by negative 3 is 1. So when I put in a 2, I got out a 1. Okay, so we're ready to graph this first equation in just a couple minutes here. Okay, all right, did not mean to do that. Let's go like this, and there we go. All right, so we have two ordered pairs that we can put, and that's not working very well. We have two ordered pairs that go to this equation over here. Now let's do the same thing to this equation. Where the x is, I will substitute 1. Remember, you can use whatever numbers you want. I'm just choosing 1 and 2. Okay, just to make it easier. 2 times 1 is 2. Bring your positive 2 over and make it a negative 2. And so we're left with negative 5y equals negative 3. Divide both sides by negative 5. A negative divided by a negative is a positive 3/5. So when I put 1 in, I got out 3/5. Okay, so we'll squeeze that in right here. 1 comma 3/5. Okay, Now let's put 2 in for x, and let's see what we get. 2 times 2 minus 5y equals negative 1. 2 times 2 is 4. Minus 5y equals a negative 1. Bring your positive 4 over, it becomes a negative 4. So negative 5y equals negative 5. And then divide both sides by negative 5 and y equals 1. So when I put in a 2, I got out a 1. Okay? So what I've done here is I now have 2 ordered pairs right here for this linear equation, and I have 2 ordered pairs here for this linear equation. So I can graph these 2 lines pretty quickly, okay? So let's go ahead and see what happens here. And here we go. Let's see, for the first equation, I'm going to go over 1 and up 1 2/3. And for my other ordered pair, I'm going to go over 2 and up 1. So the line will look basically something like this. You should use a straight edge if you can, and just kind of sketch a rough looking line, okay? Now, for this other equation, I have 2 points I'm going to plot. The first point is over 1 and up 3/5, so right there, and then over 2 and up 1, so right there. So it's very obvious where the 2 lines are going to intersect. They're both going to intersect right here at over 2 and up 1. So the answer would be 2, 1, which we already knew that because we've already solved this problem 2 different ways already using substitution and linear combination. But nonetheless, we have now solved this linear system by using the graphing method. Okay, so not too bad. All right, let's move on now to number 13. Okay, sorry about that, students. Make that number 14, okay? Number 14. And the method I think we're going to use for 14 was the substitution method. Okay, so here we go. Number 14. Now, first of all, it would be a really good idea to get rid of our fractions in the bottom equation here. So I'm going to multiply my bottom equation. I have a denominator of 3 and a denominator of 3, so I'm going to multiply the bottom equation by 3. My top equation will stay the same, x minus y equals 1, and my other equation will be, well, 3 times negative 1/3 is negative 1x, 3 times 1/3 is a positive 1y, and then 3 times 6 is 18. So there, I have now rewritten my problem by multiplying the bottom equation by 3 so that I no longer have any fractions in my bottom equation. Okay, that's a big help. Okay, so here's my one equation, and here's my other equation. Now we're going to use the substitution method. Remember, you're looking for a variable that does not have a coefficient. Well, here's one right here. This x has no coefficient, so I'm going to solve this equation right here for x, and I can do that very simply, very quickly, by taking my negative y and bringing it over and making it a positive y and crossing it off. So now I have x equals 1 plus y. So if x equals 1 plus y, then I come over here to where the x is right here, and I'm going to substitute 1 plus y. So I bring down my negative 1, then I put a parentheses, and I put 1 plus y. Then bring down your positive 1y, and bring down your 18. And now we're ready to solve for y. First of all, we cannot simplify the right side, which is just 18. However, we can simplify the left side. We can take this negative 1 and multiply it or distribute it through the parentheses. So negative 1 times 1 is negative 1. Negative 1 times y is negative y. And then plus y. Now watch what's going to happen here, okay? You have a negative y plus y, so they totally cancel out, leaving you with 0. So you have negative 1 minus 0 equals 18. And negative 1 minus 0 is negative 1 equals 18. And of course, that doesn't even make any sense. There's no variables left here. This is not even a true statement. Now, students, listen to me. When this happens, when all of your y's cancel out, or your x's, and you're left with a false statement like this, negative 1 equals 18, then the answer is simply this. no solution. Now, if you're saying, Mr. Earhart, how can we have no solution? Well, think about it. Remember, the solution to a linear system is where two lines intersect. So if two lines are parallel, like this, then they'll never intersect. And so if they'll never intersect, then we have no solution. So if we were to graph these two linear equations, you would see these two lines are parallel, and that's why they have no solution. Okay, this was a tough one. I picked this one on purpose just to make you think a little bit. Okay, all right, let's move on to the last four problems. And what they want us to do on the last four is to graph them and see if they're parallel or intersecting, or if they coincide, if they fall on top of each other. Okay, so let's take a look at these last four problems. Okay, students, I'm going to go really fast through these. So let's take our first equation, y equals 2x minus 1, and I'm going to put a 1 in for x. And if I do that, 2 times 1 is 2, minus 1 is 1. So I got out the ordered pair 1, comma 1. Now I'm going to put 2 in for x, okay? And if I put a 2 in for x, I get y equals 2 times 2 minus 1. 2 times 2 minus 1 is 3. So if I put in a 2, I get out a 3. Okay, so there we go. I have found the two ordered pairs for my first linear equation. Now let's take a look at my second linear equation right here. And let's go ahead and put 1 in for x. And again, you can use different numbers if you want to. I just choose to use 1 and 2 because they're small numbers and they're pretty easy to use. So 2 times 1 is 2, plus 1 is 3. So when I put in a 1, I got out a 3. Okay? Now let's go ahead and substitute 2 in for x. So y equals 2 times 2 plus 1. Y would equal 5. So when I put in 2, I get out of 5. Now here's what the directions say. The directions say to us to sketch the graph and then decide whether the lines are coinciding or intersecting or parallel, or could they be perpendicular. Okay, so let's go ahead and graph this first line here. I think they're going to be parallel because notice we have identical slopes right here, a 2 and a 2. Okay, but let's see what happens. We'll go for the first linear equation right here. We're going to go over 1, up 1, over 2, up 3. And then we're going to kind of sketch it. Just doing the best we can to keep it pretty straight. Okay. Now let's go ahead and graph the other line. Over 1, up 3, over 2, up 5. Yep, looking pretty parallel to me. There we go. Now let's see if that makes sense. Remember, parallel lines have to have the same slope. Well, y is all by itself, so your slope is 2. Y is all by itself, and your slope is 2. So yes, these two lines are parallel. So the answer would be parallel. All right, let's take a look at number 34. Very quickly here, let's get us a coordinate plane. There we go. And then let's go ahead and take our first equation here. Y equals 5x minus 11. And I'm going to put a 1 in for x. And 5 times 1 is 5, minus 11 is negative 6. So one ordered pair is I put in a 1 and I got out negative 6. Now, let's put a 2 in for x and let's see what happens here. Y equals 5 times 2 minus 11. 10 minus 11 is a negative 1. So when I put a 2 in, I got out a negative 1. Okay, not too bad. And now let's take a look at our second equation here. Y equals negative 6x. We should be able to do this on our head, students, here. If you put a 1 in for x right here, negative 6 times 1 is negative 6. So when you put in a 1, you get out a negative 6. Okay? Not too difficult. And then, if you put in a 2 right here for x, you're going to get a negative 12. Okay? A negative 12. So I'm going to put a 2 in for x. and negative 6 times 2 is a negative 12. Okay, so let's go ahead and graph the first line. The first line is going to be over 1. Let's make this a little bigger so we can see it. Also, I'm going to have to make my y-axis go down a little bit more, I do believe. So let's go ahead and do that very quickly here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right. Okay, here we go. Let's see. 1, negative 6 over 1, 1, 2, 3, 4, 5, 6. There's 1, negative 6. And then over 2 and down negative 1. Okay, so there's the line right there for the first equation. Okay, the two ordered pairs for the second equation would be 1, negative 6, so right here at the exact same point, and then over 2 and way down here to 12. And so the two lines do intersect. And it looks like they intersect. If this thing will quit doing this. These two lines intersect right here at over 1 and down negative 6. So your answer would be 1 comma negative 6. And you would say, yes, they intersect. Okay? All right. Okay, number 35. We'll go pretty fast here. In fact, we've done so many of these. I'm just going to go ahead and whip these last two out, kind of just going quickly. Just trust me. If you put a 1 in for x, you would get out a 0. And if you put a 2 in for x, you would get out a negative 1. Okay, you can work those out later if you want to, and you will see that is accurate. If you put in a 1, you will get out a 0. And if you put in a 2 for x and bring the 2 over, make it a negative 2, you will get out a negative 1. Okay? And then down here also, if we put a 1 in for x, let's see, put a 1 in, that's 2. Bring it over, that's 0. Divide by 2, we get a 0. Okay? And then put a 2 in for x. 2 times 2 is 4. Bring the 4 over, it's a negative 4, it's negative 2. Divided by 2 would be a negative 1. So even though these two equations, this is so cool, even though these two equations are two totally different equations, notice they're getting out identical ordered pairs. So if I were to graph this top equation right here, I would go over to 1, 0, and then over 2 and down 1, and I draw that line. Well, students, think about it for a second. If I plot these 2 points right here, they're going to fall right on the exact same points, and I'm going to get the exact same line because these 2 points are the same and these 2 points are the same. So what do we say? We say the two lines right here, we say they coincide. Okay? They coincide. So these two lines coincide. Okay? All right, the last problem. We're going to graph each one and see if they intersect. So let's see what happens here. And again, I've done a lot of these, so I'm going to save some time. And we've done a lot of these in class and in your homework tonight, so I'm just going to very quickly do these for you. If you put a 1 in for x, you will get out a 4. And if you put a 2 in for x, you will get out a 7, okay? So here's two ordered pairs that we can use to graph the first equation, okay? Now let's come down to the second equation. Let's put a 1 in for x, and if we put a 1 in for x, we will get out negative 1/3, 3, a 2 2/3. And then if we put a 2 in for x, we would have negative 2/3 plus 3. That's going to be 2 1/3. Okay? 2 1/3. So let's go ahead and graph our first line over 1 and up 4, and then over 2 and up 7. Okay? So there's our first line here. Very good. Now let's go ahead and get our second line here. And it looks like our second linear equation will have a point at over 1 and up 2 and 2/3. So about right here, over 1, up 2 and 2/3, and then over 2 and up 2 and 1/3, like this. And so there we go. Well, students, if you'll look, we're not for sure, but it looks like they're definitely intersecting. Yes, that's true. So, yes, they're intersecting, but also it looks like we have a right angle right here. So it looks like we might be able to state the two lines are what? Perpendicular. Well, the best way to know is look at your slopes. Now, please notice that y is all by itself, so the slope of the top equation would be 3. And then notice in the bottom equation, y is all by itself, so your slope would be a negative 1/3. Do you see that okay? So with that in mind, we ask ourselves, are the two slopes opposite? Yes, one is positive and one's negative. And then we ask ourselves, are the two slopes reciprocals of each other? And the answer is yes. They're both reciprocals of each other. So these two lines intersect, and yes, they are perpendicular. Okay? Now, I hope this homework help video has been a help to you. Okay? And definitely call me or contact me if you have any questions.